Namaste to all my dear students. I welcome all of you in Antiwhite's YouTube channel. Today we will discuss about the question paper of quantum mechanics of BSc's third year, which was asked in supplementary examination held in October-November 2022. So this question paper is constituted of 50 marks and we have to attempt all questions in 3 hours. In a nutshell, there are 5 questions in all and we have to attempt one question from each section, and section A is compulsory. So we will start from section A, which is compulsory question. We have to attempt all parts of this question number 1. So question number 1, first part. Which of the following is a way to find the expectation value of a physical quantity? So the right answer is A. Its second part is, what is a Hamiltonian operator? So basically, Hamiltonian operator is the sum of kinetic energy operator and potential energy. This Hamiltonian operator gives the total energy of the quantum mechanical system, and we write down the Schrodinger equation like H psi is equal to E psi. E is total energy, which is the sum of kinetic energy and potential energy. So this was Hamiltonian operator and its significance. Its third part is, find the linear momentum of a photon of wavelength. So we know the de Broglie equation, in which the wavelength of a particle is equal to h divided by mv. This mv is momentum, so h upon p. We have to find momentum. So p is equal to h divided by lambda. H is Planck's constant and lambda here is 1 angstrom. So we have to convert unit and then we can find out the value of linear momentum from this equation. Its fourth part is, which of the following can be described by an asymmetric wave function? So option A, electron, B, neutrons, C, protons, and D is all of these. So all these 3 particles are fermions, and we know that fermions can be described by asymmetric wave functions, while bosons are described by symmetric wave function. So right option is your D. All of these particles can be described by asymmetric wave function. Part number 5, the minimum energy given by quantum mechanics for a harmonic oscillator is. So we are talking about minimum energy. For minimum energy, n, which is a quantum number, is taken is equal to 0. So minimum energy of harmonic oscillator is half h cross omega. We know that what is h cross. H cross is equal to h divided by 2 pi, and h is Planck's constant. Next is, what is the value of Bohr magneton? So the value of Bohr magneton is E h cross upon 2m. C is the right option. Next part is possible values of J. J is total angular momentum quantum number, and possible value of J for L is equal to 0 and S is equal to 1 by 2. So possible value of J are L plus minus S. L is orbital quantum number, S is spin quantum number. So here L is equal to 0 plus minus and S is equal to 1 by 2. So possible values of J for this combination is plus minus 1 by 2. But there is given 1 by 2. So this is also a possible value and right option is C. Section B, question number 2A part, obtain time dependent one dimensional Schrodinger equation of a particle. So we have to derive time dependent Schrodinger equation of a particle. Then its B part, calculate the expectation value of momentum of a particle trapped in one dimensional box of length L. So expectation value of momentum P is equal to, a dimension are given from 0 to L. Psi star momentum operator psi into dx, because it is one dimension we have taken dx. Now we must have to know the formula for momentum operator minus iota h cross curly upon curly x. What is h cross? H cross is equal to h divided by 2 pi. H is your Planck's constant. And then what is wave function for this one dimensional box in which a particle is contained? So wave function is psi is equal to under root 2 upon L sine kx, sine kx. So we have to put these two formula in first one and have to calculate the expectation value of a particle contained in one dimensional having dimension of length L. The next is question number 3. State and prove Heisenberg uncertainty principle. So Heisenberg uncertainty principle states that it is impossible to measure simultaneously the accurate value of momentum and position. So we have to prove this statement also by taking one or two examples. It's B part. Write short notes on the following. Number 1 is energy operator. So what is energy operator? It is Hamiltonian operator basically. Iota h cross curly upon curly t. And second one is momentum operator minus iota h cross curly upon curly x. So we have to discuss these briefly also. Section C. Question number 4, A part. Obtain the expressions for energy levels and normalized wave functions for the ground states of a harmonic oscillator. So we have to derive expression for nth energy level, which is quantum mechanical concept, and nth energy of nth energy, and energy is given as n plus half h cross. So for a ground state, n is equal to 0, En is equal to half h cross omega. We have to derive this expression. It's B part. How one explains the 0 point energy of a harmonic oscillator. So we have to define what is 0 point energy. So it is minimum energy of harmonic oscillator when temperature of the body is 0 Kelvin. So 0 point energy does not mean that the harmonic oscillator has 0 energy. It has minimum energy, and which is not 0 quantum mechanically, and E is equal to half h cross omega. We have talked it earlier also. Then question number 5. Derive an expression for the transmission probability through a rectangle potential barrier for a particle having energy lower the barrier height. So we have to derive an expression for transmission coefficient which is not equal to 0. There is a probability of tunneling the particles through this barrier having finite width and larger height. Section D. Question number 6, A part. Using separation of variables, derive 3 independent equations for the hydrogen atom in spherical polar coordinates. So we have to derive 3 equations. First one is a radial equation for r, then theta, and then phi. We have to derive three different and separate equations for a hydrogen atom. Its B part is, what is the physical significance of magnetic spin quantum number? So what is magnetic spin quantum number? ML. So ML, what is ML? ML refers to the projection of the angular momentum in arbitrary chosen direction. And what is arbitrary chosen direction? It is z direction. So we have to find LZ. Lz is equal to ml into h cross. So we can illustrate this phenomena like this. This is arbitrary z axis where Lz is here, and what is ml here? Ml is projection of L on this Lz. So this is first projection, second, and similarly like in downside. Let's understand this by taking one example. Here we have taken L is equal to 2. So for a given L, there are 2L plus 1 values of ml. So possible values of ml are here 5. And what are they? They are -2, -1, 0, +1 and +2. So for a given L is equal to 2, ml have 5 values which are equal to -2, -1, 0, +1 and +2. So for these all 5 values, Lz become equal to mlh. So Lz also have 5 different values: ml -2 h cross, similarly -1 h cross, 0, 0 h plus and plus 2h. So in this diagram there are 5 Lz values corresponding to 5 ml values. So basically ml gives the quantization of angular momentum. Next is question number 7. Explain Stern-Garlich experiment. Discuss the result obtained with the mathematical treatment. So we have to explain its experiment and then discuss theory. And what is its significance? This gives the quantization of angular momentum, that is quantization of spin. This famous experiment proved that spin is quantized and S has ±1 by 2 values. Two values are there. Section E, question number 8, A part. What is anomalous Zeeman effect? Give its quantum mechanical explanation and expression. So under the influence of magnetic field, the energy levels of an atom are splitted. This is called Zeeman effect. When magnetic field is weak, the energy levels splitted into 3 and 4 components, which is called anomalous Zeeman effect. So we have to derive it quantum mechanically also. Its B part is explain JJ coupling. So JJ coupling arises when there is interaction between electrons and neutrons of the nucleus, and it is observed in your heavy atoms, that is atoms having large number of electrons and neutrons. Question number 9, its A part. Describe helium atom spectrum. Discuss the difference between orthohelium and perihelium. So there is a difference between the spins, and we have to explain this difference also by using the energy level diagram. Last part is B. Calculate the Landé-G factor for the following states. So what is the formula of Landé-G factor? I will write here. G is equal to 1 plus J into J plus 1 plus S into S plus 1 minus J into J plus 1 divide by 2J into J plus 1. So this one is separate. 1 plus this thing divided by 2j into j plus 1. J is total angular momentum quantum number, S is spin quantum number, and your L is, this is L is orbital quantum number. So term is 3 2s 1 by 2. So compare this term with n L j 2s plus 1. Here n is 3. N is not used this Landesi factor. Here n is 3 and s is equal to 2. So compare here capital S is S mean L is equal to 0. So in first part L is equal to 0 and 2s plus 1. This 2s plus 1 is equal to 2. So 2s plus 1 is equal to 2. This implies s is equal to 1 by 2. And j is here 1 by 2. J is 1 by 2. So we have obtained the value of L, which is 0 for capital S, and small s is 1 by 2 and j is 1 by 2. So we can put these values in this formula and find out the value of g. Similarly, in second term n is equal to 4, which is of no use for us in this formula, in this calculation. And what is your term? N L j 2s plus 1, 2s plus 1. So here n is equal to 4 and L is equal to P, capital P. So capital P, L is equal to 1 and 2s plus 1 is equal to 2. 2s plus 1 is equal to 2. So s is equal to 1 by 2 and j is equal to here 3 by 2. So j is equal to 3 by 2. So we have calculated the values of small l is equal to 1, small s is equal to 1 by 2 and j is equal to 3 by 2. And we apply the formula which I have also talked earlier, 1 plus this. So we have calculated here j is equal to 3 by 2, s is equal to 1 by 2 and L is equal to 1 for P. So we can calculate Landesi factor for it. So this was all about your question paper of quantum mechanics, which was asked in your supplementary exam. Thanks for watching and listening.